Okay, today on 4.2b, we are continuing with our unit circle, but more specifically in terms of our sines and cosines and all those trigonomic functions of our unit circle. So let's go back and review a little bit of something that we touched upon way back in the first semester is functions in general. And in sines, cosines, uh, the different trigonometric functions, if you were to just graph, right? Let's say if you were just to graph the sine of something or the cosine of something, they are considered periodic functions. And periodic functions, basically, it's just like saying, say, if f of t plus c, then there has to equal, there is a real number of f of t plus c where f of t plus c equals the original f of t, which is just a fancy way of saying it repeats itself. So a periodic function kind of repeats itself if it's not the best picture, but we all know by now, I am not the best drawer. But it's saying that the function will repeat itself again and again and again. So this helps us evaluate different numbers, different degrees that don't normally fall within our unit circle, because we can use what we already know within the unit circle, and they will have the exact same value within that unit circle, even though that number falls out of our unit circle. Like instead of having anything within that 360 degree, let's say we were given 700 degrees and so on, and they wanted us to find those trigonomic functions. Well, the wonderful thing is our trigonomic functions are periodic and they repeat. So that helps us in that case. Also with the periodic functions, another just a little a little reminder, if our function, right, if we get an f of negative t and we put it into our function and somehow it comes out as the negative f of t, right? It's a negative answer. This function is odd, right? So if we, like a linear equation is odd, but if we get like f of, let's say, negative t and it always comes out positive, like f of t, just a quick reminder, this is an even function. Like if we were given an x squared even function, we put in that number, we're gonna get an even number out of it. So here, let's go down to and do some examples. Let's say we were given, for example, let's do one that we would know. Let's say we're given t of negative 3 pi over 2. If for those of you that likes to use degrees, and I for one visualize it better with degrees, this is negative 270 degrees, right? 3 pi over 2, 1 and 1/2. Is it 270? Yes. 180 plus, yes, it's 270. So negative 270, we start here, we go all the way in the negative direction, right? Clockwise, and it would actually end up right here, this being negative 270 degrees. Or, as I'd like to think of it, it ended up at pi over 2 in terms of our radian. So this is pi over 2, and remember our unit circle, our coordinates are 0, 1 for our unit circle here. So then if we had to do sine of t, cosine of t, tangent of t, So sine of t, right up top, it's opposite. Our sine of t is our y coordinate, so that would be 1. Our cosine of t would be our x coordinate. So for those of you that know, sine and cosine is always considered our x's and our y. So this is sine is always y, cosine is our x. So cosine of t would be 0. Tangent in this case, tangent is opposite over adjacent, or in another way that you can think about this, our opposite sine. Tangent is also considered sine over cosine. Well, here sine is 1, cosine is 0. We can't have divided by 0, so this does not exist. This is not impossible. This is not possible. Not possible. It's impossible or undefined. We'll call that undefined. Undefined. Does not exist. Or does not exist. Undefined. Let's just say undefined. Let's do cosecant of t, secant of t, and cotangent of t. So secant of t is the inverse, or in this case, the inverse, which would be divided by 1, which is just 1. However, our secant of t would be our inverse, would be 1 divided by 0. That in itself is also undefined. We'll just put that here, undefined. And then cotangent of t would be then 0 over 1, which is just 0. Let's think of, let's do another example further down, but this time let's say we are given sine of 13 pi over 6, and we want to know what that is, right? So let's think about this normally. What I want to do is I want to, since sines, cosines, tangents, all those functions are periodic, I can take away 360 degrees, or in this case, taking away, since this is in radians, I take away, we're going to just strip this down until it gets below 360 degrees, or 2 pi, until it gets within the range of the unit circle. So 13 pi over 6, I'm going to subtract 2 pi. I'm going to keep subtracting 2 pi until I get, well, a factor of 2 pi. But 2 pi first. So 2 pi, so that makes what? 2 times 6, that's 12 pi. 12 pi over 6, that gives me pi over 6. If I think about what pi over 6 is, that is 1/6. That falls somewhere, this is positive 2, so this falls somewhere here. Pi over 6, and pi over 6 is, what is that in degrees? That is our 30 degrees. So this is 30 degrees. Our theta is 30. Well, I can do that, right? I know this is, if this is 30, if I drew this, this is 1, this is root 3, this is 2. So I know my coordinate has to be root 3 over 2, comma 1 over 2 for my x and my y's. And so to find the sine of that, the sine of 30 degrees, well, that is 1. Opposite over adjacent, that's 1 over 2. So the sine of that must equal 1 over 2. Just like that.